Welcome to step 2 for generating a geologic map using digital resources for field 2. What we're going to do at this point is use Google Earth to generate as much data as we possibly can for pushing it on to the next step in mapping. Google Earth isn't going to be the final product. The KMZ that we produce is not going to be our final map. We're going to have to take that, import it into at least one more, if not two more software packages. So before spending a huge amount of time on this, I would recommend kind of creating a basic file and then moving on to ArcGIS to see exactly how much information you can pass along. So to start with, we are going to open up the Bradshaw KMZ that I gave you originally. This has a handful of features within there. It has polygon features such as, I will turn all these off, such as the map area that I want you to actually produce the map of. We've got the A to A prime cross-section line. We've got this viz near-infrared imagery, the TIMS where the vegetation is masked out, and I actually included a TIMS where the vegetation is still in there, but it comes out as this blue color. And then we have this geologic map that will hopefully help you interpret to some degree. All right, so meanwhile, you're probably not going to use the Aster Viz Near Infrared because the Google Earth imagery is a bit higher resolution. But what we want to do is simply figure out where we were when we did this mapping. So to do that, we're actually going to use the GPX file that we generated, and I called it example.gpx, and we'll create line strings as well as tracks. So within here, there are tracks that we actually hiked along that the GPS was recording as you were over time, and we also have these waypoints. So if you open this GPS device folder, you can see that there are waypoints and tracks within there. And when you look at all of these tracks, there's a whole lot of them. And anytime that you were recording, anytime that the GPS was on, it was recording one of these tracks. Turns out tracks are actually not all that important. Much more important is are the waypoints that we collected while you were out there. So to start with, I'm simply going to take these waypoints and drop them into my Bradshaw.kmz. We're not going to use the tracks unless you actually hiked along some boundary along the way. But you should use that as you see fit. Meanwhile, we have all of these waypoints. These were specific locations where you either noted a lithology or took a strike and dip. Alright, so these are going to be passed along to our final map, but what we're going to do now is simply try to interpret as much as we possibly can. We have a couple of different resources to do that. Of course, we have visible imagery. We also have this TIMS data set, and the TIMS data set doesn't perfectly line up. But one thing that we can do is actually turn down the opacity on the TIMS data so we can actually use it to some degree to interpret what was going on. Now we can see that, let me turn the opacity back up, we can see that this is where the road is supposed to be, and when we see in Google Earth imagery, it's off to some degree. So it doesn't perfectly line up. I think it lines up a little bit better up in the north, where we can see different compositions coming out. Alright, so we've got these tools. You can turn them on, turn them off, turn up the opacity, turn down the opacity in order to draw some lines on this map. So to begin with, let's simply start with our day one where the vans were parked down here and we hiked up the mountainside to see a change in lithology up here. Now it turns out that that lithologic change looks pretty obvious. If we turn up the opacity on the TIMS, we can see that it's this yellow to reddish feature. And so what I'm going to do is simply say that I've got a pretty good idea of where that lithologic changes, and I'm simply going to drop a path along that line. So if we saw the change right in here, I'm going to say I'm pretty confident that right along this line is where we can see this change from this brighter surface to this darker surface. And I will call this whatever I would like to call this, let's say boundary 1. Alright, so there's boundary 1. And then I can see that there's another lithologic change up here. Maybe slightly harder to see depending on how you orient this. But certainly there's a decent amount of float. But I will create another boundary right in here, right at the base of this slope. Probably comes along something like that. And So this is about as good as we're going to be able to get in terms of resolution of these features. Now we'll call this boundary 2. All right, so these are our known boundaries between lithologic units. If I go to over to another spot, let's say somewhere around here, you hopefully made observations that correspond to the lithologic changes as well. So if I were to throw in another random boundary right in here, we've got this change from brighter surface to darker surface, and using the 3D in order to view what's going on might be pretty useful. If I put a point there and I tilt it, you can kind of see that reddish layer right at the base of that line. Now, you should feel free to test these things out. All right, so there's a line that I have kind of right in the middle of that red line, or that reddish feature, and I can turn on the TIMS and see if it corresponds. TIMS is pretty coarse at that resolution. I can, of course, turn on this stretched Aster Visner infrared and see how it looks any differently. All right, now you can modify these things relatively easily. I'm going to go in and I'm going to edit boundary number 3, and let's say I want to continue it along this line of kind of interesting color change, and then it kind of dead ends there. So you can go back, you can modify these things relatively simply by just right-clicking on these and hitting the properties and changing these properties. At that point, all the points become active again. All right, so you're going to do this for as much as you possibly can. You can draw polygons, and let's say I'm going to draw a very coarse polygon down here for 1 unit. And I'm going to name it CBQM. What happened to my polygon? And if I change the properties, I can say, I can make it a coarser line. I can give it a different color. We'll call it red. We will fill it with red as well. And it's not coming up on my, why isn't it? Oh, because it's probably hidden behind one of these guys. There we go. All right. So you can create as many polygons and lines as possible, because the next step that we're going to take, we're not going to have the ability to kind of dump information back and forth quite as flexibly. All right, so in the end, we have a bunch of different data products, and what I'm going to do is pass some of this along to the next step when we open this up in ArcGIS. So what would make the most sense is I'm actually going to create a new folder. So I'm going to add a folder called Mapping Features, and within this mapping feature folder, I'm going to drop the map area that I'm interested in, the A to A prime, each of these boundaries, and there's my crazy basin quartz monzonite. Now you can drop in these images as well. I'll drop in the waypoints. The idea is, if you spend a decent amount of time building up these lines and polygons, the more information you're going to have for generating your final map in the end. All right, so now I have this folder of mapping features, and what I'm going to do is simply save that as a new KMZ. So here's my new mappingfeatures.kmz. I'm dumping it to the desktop, and when I look at my desktop, there is my mappingfeatures.kmz. All right, so just generate something relatively simply so that when we dump it into ArcGIS, you can see how much information transfers along and what you have to work with. Meanwhile, that's step 2, and next step will be ArcGIS.